All right, 7:10, let's get started. Great. All right. Ian, do you want to start sharing audio too?
That makes more sense. Okay. Yeah, we have a pretty full agenda today. We have a lot of presentations, so we'll have to be careful about keeping on time. We have some. So for existing work, we have Greg speaking about option TLV, an update on the IPPM capacity metric draft, and the in-progress IOAM draft. And then we're also starting to look at some information on and presentations on spin tests. These have been presented other places, but we thought it was time to start doing a little bit of that work in IPPM. And then the remainder of the time will be spent on lightning talks, which are on the agenda but are not on these slides. So draft IPPM stamp, option TLV is an ISG evaluation, and IOM data is sent up for AD evaluation. That's about it.
If Martin is here, I don't know if you wanted to make any comment on the status for the IOAM data draft and what we want there.
Sure. Yeah, I did read IOM data. It's in pretty good shape. I did have a small number of comments that are stored in somebody's inbox. Please reply to them. I've marked as revised ID needed. I'm happy to discuss that. Maybe that's not the case, and we should just ship it the way it is and just do the fix later. But I would like a reply. That's all that's blocking it right now.
Sounds good. Thank you.
All right. Sorry, I'm just trying to get myself set up to see if I can get it so it advances a little bit better.
Sure. If you go into full screen mode, shouldn't you be able to go through?
Yeah, I can paste through in full screen. Okay, I'll just do that. I just can't see Meet Echo anymore, but that's fine.
I'll keep track of Meet Echo.
Okay, great. Then we're all set.
So yeah, let's begin with the updates on stamp option TLV from Greg.
Okay, great. Thank you. Next slide, please. So we went through the working group last call, AD review, IETF last call, and ISG reviews. And many thanks to Rakesh and Martin. And I don't know if anybody from SecDir or GenArt reviewers in the last call or ISG here, but it was very good discussions, and let's see what changed. Next slide. Okay, the TLV format. We introduced the flags field, and 3 flags been allocated to indicate the unrecognized message type, malformed TLV, and failed to do authentication or integrity failure. No, integrity check. Others are still available, and well, it's a kind of scarce resource, so we'll be careful allocating them. Next slide, please. There was some clarification to the text that extra padding is filled with the pseudo-random numbers. The stamp TLV, we added optional TLV, so basically made it not fixed size but variable length for the possible future extensions. Clarified how the integrity check works with the HMAC, and what we've done is there was very good discussion about the original proposal was to use the text only in TLVs, and it was pointed out that this way it creates a possible, basically absence of any connection between the base packet and their extension creates the possibility of replay attack. So what we added is that the sequence number in a base packet is used to calculate the HMAC digest. So thus it creates a link. And several updates in IANA considerations. Next slide, please. Location TLV. It's changed because a very interesting scenario that we originally missed is that if between sender and reflector we have NAT64, so thus one cannot know what their address family will be returned. So because we are supporting the symmetrical packet size, we worked out and introduced sub-TLVs. And that, in addition, that it addresses a comment we had for MAC address length, because there is a 48 bits and 64 bits MAC addresses. So now IP addresses in the MAC address, they are queried using the sub-TLVs, and then the sub-TLV is the size of to accommodate the longest possible data. Next slide, please. So we still have some discusses that all the comments were acknowledged and responded to, changes proposed, and I believe that after the meeting we'll just resume the discussion and publish the new version.
All right, thank you so much. We have a couple minutes if anyone has any questions on that or wants to make any comments on those last changes and updates we have for this draft. And I would encourage people to read the updates, since, as Greg mentioned, there are some pretty interesting bits in there. Okay, sounds like we can move on. Thank you, Greg.
Mm-hmm.
All right.
Okay, thanks. Thanks, Tommy. Thanks, Ian. I can see my first slide here. I'm just going to back up to chair status and mention that the route metrics draft didn't appear there, but it's a it's in IESG on the telechat agenda for next time around.
Yes, thank you for bringing that up.
Okay, so I'll try to keep this to 5 minutes. The clock is operating. So this is a draft that I'm writing with Rudiger and Len Chavitone. And let's go to the next slide. And I'll try to cover these first four really quickly. So here's where we're going to end up today, trying to reach consensus soon so we can start protocol support. And that means getting agreement on the metric and method, and try to trigger any concluding reviews with the working group last call. That's where I want to end up today. Next slide. So here's some quick background, and if you haven't seen this before, you can download the slides and dwell on it as long as you need. The three main points are this is a receiver rate measurement we're depicting here. You can see trial results taken about every 50 milliseconds in the current system, and the time divided up into sub-intervals of a total test interval. And there's feedback from the receiver on the test stream to the sender, which includes the rate measurement and loss, delay variation, out of sequence packets, and so forth. So those are the kinds of things that are happening in this method and metric. Next slide, please. So here's where we define the metric. It's the maximum IP layer capacity, which includes the headers and the UDP headers and payload and so forth. This version of the metric follows the IPPM framework, which is to define first a singleton, which are the DT measurements, sub-interval measurements, and then looking at a sample of those, which in this diagram below is 10, and then finding the maximum of those 10 measurements. And we've defined it in words and an equation, which is kind of the typical thing that we've done in IPPM. Next slide, please. So here's the draft status. We've been getting additional comments and reviews from lots of places. The ETSI STQ Mobile Technical Committee, which is a good one. We certainly want this to be applicable to the mobile environment. Broadband Forum in the context of preparing their technical report. And a new one this time around is the FCC Working Group on Gigabit Access measurement in the United States. Some interesting feedback from those folks there. Unfortunately, it's up to me to transfer all this good knowledge and comment into the document. Also, 4 new members of ITUT Study Group 12 who are testing companies, and they've provided their feedback. So in version 2, the access policies are basically a new area that we discussed in the FCC group, where we've got new references for things on the load adjustment for a running code section, and we're referencing the Broadband Forum TR on 471 for the information model and reporting. So there's no need to repeat that here. There's an excellent reference, many large tables there. Next slide, please. So a quick global status is that this is approved in ITUT Study Group 12 and in ETSI Technical Committee on Speech and Multimedia Transmission Quality. And now, just last month, Broadband Forum approved this document as well. We've also got a new supplement in the ITUT Study Group 12 interpreting the capacity results, kind of our measurement considerations. We're still, our draft is adopted, of course, in IPPM, and 2 new items down at the bottom there that are going to be a little bit of a surprise. The ETSI STQ Mobile Committee is taking this up as part of their 5G performance measurements, KPIs and QoS, and there will very soon be an open broadband UDP-ST utility project announced soon. Next slide. So, like I said, we're seeking last call, and the reason for doing this in multiple standards bodies is buttressed here by the XKCD cartoon. We certainly didn't want to just add another competing standard. What we've tried to do is do the a unique approach where we've tried to produce 4 harmonized standards across STOs. And basically all my friends, when I started out trying to get 4 standards, everybody said, well, Al, good luck with that. And we all know what that means. No one thought it was going to happen. And we're actually pretty close to that right now. And we're actually doing better than that. We're getting some help, got some help with the running code, got some help in an additional standards body on mobile and 5G. So I think it's would be a good time to start a working group last call here. And that way we can move ahead with knowing what we want to develop in protocol development for STAMP and TWAMP and so forth. Thank you.
And the document seems pretty stable at this point, so it seems like a reasonable time to go to last call. I think we're at a good place with our queue. Just, I guess, very quickly, if anyone does have comments or thoughts, please speak up now, and would encourage people to make sure that we're reading any of our documents like this. And I think the last call would be a good way to trigger that more attention. So, sounds good. All right, seeing no more comments, I think we can move on.
Thanks very much, Tommy. Thanks again.
So.
Oh yeah, you're gonna have to flip through a lot of junk here. Sorry. Okay, there you go.
All right. Hello, Frank.
All right, so hopefully you can hear me.
Mm-hmm.
Can you? All right, so I think the IOM section is 3 portions. And the first one is on V6 options, and I'm going to go cover that. The second 2 portions will be covered by Tal. So on the V6 options, next slide. That draft has been an individual draft for a while, and it's basically, could you go to the next slide? Maybe. Thank you. And given that it's just asked for the allocation of 2 values, it's a relatively short document. And it's been stable, and the early allocation, thanks for kicking off the process a while back, has been completed. We have early allocation that's going to go last until April next year. And I know that Justin, that we have on the call here, is already using those for his Linux kernel implementation. As part of that implementation, he and Tom spotted a problem that Tom Herbert also brought to the list, and it's about the forwarding behavior of nodes that don't necessarily support IOM, and well, that needed clarification because there is a contradiction in there. Next slide. Let me go and give you a little bit of background so that we understand what the problem is about. We've written a document, which is kind of a sister document to the working group document that is adopted, a deployment document for IPv6 that tells how to use these options. And there we clearly spelled out that IOM domains are either bounded by hosts, so a host inserts the IOM option extension header, and it's going to go and remove it again at another host, or they're bounded by networking devices. And in case they're bounded by networking devices, it is always the case that we do a link up. So the packet will always be encapsulated into an IPv6 packet, and that v6 packet will carry IOM extension headers, which means that by no way packets could go and escape from that particular IOM domain, which is something to keep in mind because there's been a paragraph in the document that causes the confusion that was about escaping packets from a particular IOM domain. Next slide. To expand a little bit on, well, the forwarding, what happens from a forwarding perspective and what nodes need to be and not need to be aware of. Again, a little bit of background on the various trace option types, or the various option types that we have in IOM. I think the key highlight is that not all nodes in an IOM domain are necessarily required to be aware of IOM. In tracing, you want to go and decide which points you want to go and trace in a domain. In proof of transit, you obviously only have those nodes probably enabled for IOM. Where you do want to go on proof transit, same thing for direct export. You're only going to go and enable those nodes that necessarily need to go on, that you want direct export from. And well, for E2E, maybe you only want to go and enable the option, the edge nodes of a particular IOM domain. So I think it's important to recognize that not all nodes need to go and do that, which is why, next slide, from an early allocation perspective, what we asked for is, well, we got two values allocated, and one has a 1 in the third bit because it might change en route for tracing and for proof of transit. And the first one, and what they both have in common is that they both say in the two first bits 0, 0. If you don't understand, then skip over. I think that makes sense because not all nodes necessarily, as I said before, need to go and support that. Now, with this in mind, let's look at the problem. And the problem is on the next page. If you can flip forward. What the text in, and that's a little bit of a leftover from the very early discussions that we had in 6-man. What the text says right now is that nodes need to be explicitly configured on a particular interface to go and support IOM. And otherwise, you would need to go and drop the packet. And that obviously contradicts with the 0, 0, 2 bits in the starting point from a v6 perspective in the option allocation. Now, that was originally put in because of concerns that packets might escape a particular IOM domain and then cause harm and confusion to people that have no clue about IOM, don't understand it, and don't want to go and see it. And okay, that's fine, but the world has moved on since that. We have the deployment draft for IOM over v6, and that very much contains IOM to a domain, as I said before. So we can simply remove this text, and we have consistency, and we don't really have a problem. So it's a very, very straightforward fix to a problem that we, well, had no proper solution for when we initially wrote the text. But since the world moved on and progressed and we have the deployment draft, I think we have a solution now. It's just like the text is no longer required. We can remove it. Next slide. That means proposition is very simple. And that's also what I said over the email list on, I think, Wednesday when I replied to Tom. Let's get rid of that paragraph if everybody's fine with that, because we have a good solution. And that good solution is pretty much framed by the deployment draft. So my question is, shouldn't we go and adopt the deployment draft also as a working group document so that it can go and progress as a sister document with the options draft? Because it shows here that deployment context is important for people who code up an IOM implementation. But the thing naturally came up because of Justin's work on the kernel implementation. So I do believe it has some merit that we make sure that this document stays. That's it. Any thoughts?
All right, thank you. If people want to comment, please get in the queue. I guess one question here. Do we see the need for this to be a separate document, or can we just fold these deployment considerations into a section of the document that defines the v6 option itself? Is there a reason not to combine them in that way?
Well, you can argue, right? So I think the original idea was the v6 options document for sure needs to be standards tracked because it allocates, or it has a request to IANA, right? Sure. And the deployment draft was more like something, yeah, we could go keep it informational. And originally, we just supplied it as something that is as an FYI so that people understand really how it's been used. What we see right now, there might be a benefit to provide for longevity so that it stays. So I'm fine either way. We can go and fold it in. We can make it a longer document, or we can go and have it as a separate document. I think it just there is merit to go and keep it.
Yeah, I mean, particularly the paragraph that you were referring to, if it is, if it was originally brought up as a concern in the kind of the standards track document of saying we need to make sure that this is contained.
Mm-hmm.
If our replacement for that is saying, oh, we do have a containment mechanism, I feel like that should be part of the standards track document. And it's totally fine to have a section in your document that is, here's an informational example about how to do this, but still have a normative requirement in the same document that says you must be able to contain this to a given domain. We do have someone in queue. Call you. Do you want to come in? Oh, yes.
Hear me?
Yep.
Can you hear me?
Yes.
Oh, okay. So I just want to let the audience aware that later we will have a short talk and actually relate to this draft. And in that talk, we particularly concern about the buffer, passing buffer issue, and suggest some alternatives to avoid the big overhead introduced by the potentially large IOM data in the HBH option header. So we think that's a potential issue faced by this draft.
Okay, thank you. All right, do we have any other opinions from the group on the status of kind of including the deployment considerations within?
Could we get any kind of hum, whether we, or Tommy, should we just fold it in and merge the two documents? We can go and do that if that's what the working group wants. Or we can also adopt it as a separate one, right? So that decouples the getting the option definition relatively quickly and kind of fleshing out the deployment in greater level of detail. Maybe that's something that How You was referring to, right? Because I think there is benefit of having the numbers stable.
Sure. I don't think that's either way. We probably would want the documents, if they were separate documents, to be aligned. So I mean, we can work that out. Yeah, I mean, if it would be helpful, we can do a quick hum. So if everyone knows, the hum tab is their little graph bars over on the left. So I think we have a couple different options here. One would be, is the working group okay with kind of merging in some of the deployment advice about how to contain the v6 options to a given domain into the existing document? And I think that would be something we have to confirm in the list, but I'll ask that first. Second, if people don't want to do that, but they want to adopt it as a separate document. And then third, do they not want to at all? So I guess I'll start a hum now. And please go over to the hum tab and hum softly or loudly if you believe that we should incorporate the v6 deployment considerations into the v6 options document to clarify the scope of how these options can stay within a domain. You have 10 more seconds. Got a piano. Okay, so quiet. And comments on Jabber. Let's do the second hum for, do we want to consider adopting the v6 deployments separately? I'm going to start that now. also piano. And I guess last, if you think we should not adopt this at all. More seconds. Yeah, next time we need to make these hums faster. Pianissimo. Okay, so it sounds like we have overall feeling that we want to put something of this in. It seems like the group doesn't really care if it goes in the same document or not. So I think we will talk with our AD about what we prefer. Personally, I would lean to having it be in the same document, and we will move forward from there. Sounds good?
Thank you.
Alrighty.
Over to Tal.
Great. Oh, Martin?
I think it might be worthwhile to see if there are any strong objections in any of those camps, or if it really is just people have mild preferences for one or the other.
Yes, that's a good point. If anyone does have any strong feelings one way or the other, please speak up or write that in Jabber. And in the interest of time, I'll let Tal in. All right. Thank you, Frank.
Hi. Can you hear me? Can you see me?
Yep.
Okay, great. So a few words about the flags draft. Actually, in the last few days, we posted draft version 02, and it's the same as 01. We just wanted to avoid expiration. Next slide, please. So a short update. In version 01, which we actually discussed in the previous IPPM meeting, the main change we applied back then was to change the security considerations, and specifically we discussed the amplification attacks. And I think the general feedback we received back in that IPPM meeting a few months ago was pretty positive, and a couple of people said they still wanted to review it again, but I think we can expect probably to get some more comments in working group last call, but at this point, it seems to be pretty stable at this, at least from this perspective. Otherwise, the main open issue that we still need to resolve is the open issue around the loopback flag. So a few words about that. Next slide, please. Okay, so regarding the loopback flag, we actually also discussed this in the previous meeting, but when we use the loopback flag on the reverse path, IOM nodes need to know that they don't need to push IOM data. Okay, so we need some way to distinguish between the reverse path and the forward path. And there were a few possible methods to try to detect this difference. One was to use a new flag. Another approach was to use a new IOM type. And there was also a possible approach to clear the remaining length field to 0. So each of these approaches had its pros and cons. Generally speaking, if anyone has any thoughts about that, would be happy to hear either right now or on the mailing list. And I think anyway, we want to resolve this issue, so we'll probably continue the discussion on the mailing list, hopefully to resolve this soon. So any other comments about this issue?
Greg, go ahead.
Greg, we can hear you.
Thank you. I have a question about, and I don't think that we have discussed it earlier before, on active flag. So we do have a set of active OEM protocols for performance monitoring, defect detection. So what do you see as the benefit of creating this flag in IAM rather than, if there is a need, to include IAM header into existing protocols?
Yeah, so I believe actually this question was raised before, and there is a specific section in the draft that was meant to address this question. So there's a section about use cases where the active flag is used, and that section describes, I think, 2 use cases, if I remember correctly. One of them was basically, like you said, when you use active protocols, which are not defined in this context, you may want to also include an IOM header and to have IOM nodes along the path push their IOM data. So in that case, the active flag is a way of telling the IOM decapsulating node that it needs to drop this packet. That was one use case. Another use case was basically the scenario that we called cloning or replication, where basically you have data packets which are forwarded along the path, and then there's the IOM encapsulating node, which may replicate some or all of the packets, and the replica, the copy of the packet, includes the active flag. And again, that replica follows the same path, has the IOM data pushed into it, and finally the decapsulating node, but based on this active flag, knows it needs to terminate. So these scenarios are already discussed in the draft, and again, we put this section into the draft as a response to the question, what is the use case for the active flag?
Again, I have a concern similar to what we had the discussion with the loopback, because the security implications, especially if there is a replication and creation of like multiple shadow copies of the data flow. Yes, it is very tempting to use it as a attack vector.
Right, and again, this goes back to the amplification attack, and also this is addressed in the document. So again, when we discuss the amplification attack, we address both the loopback flag and the active flag, and I believe the text right now at least analyzes that aspect and proposes mitigation methods.
Okay, I'll read it again, and we'll continue on the list. Thank you.
Thanks.
Yeah, I think in general, I'd like to see more reviews from the people who have concerns about this, because I think they're important to address before we move this further. Looking at the notes from last time, I think it sounded like Martin Duke and Brian Tremble had offered to kind of review this more. I haven't seen activity on the list, so I guess I would ask them again to kind of give consideration to this. Another option we have is kind of asking for a specific security review of this and to see if we can get more thoughts on the amplification attack vector to make sure we have a solid answer there.
Right.
Okay. Brian?
Yeah, I would like to actually, I do that too. I would like to have a chance to do that review before we send it in for early security, because I think, yeah, for obvious reasons, I don't want it to get killed in the early security review.
Yep. Yep.
I just haven't had a chance to look at it since since April, I haven't actually paid any attention to IPPM since the last meeting, and I do need to pick this back up. So thank you for the reminder. I will try and get that done in the next couple of weeks, and we'll challenge Martin to do the same so we can move forward on this.
Perfect. Thank you both. Okay. Let's quickly talk about direct export. I think it's in a relatively similar boat. So if we can make this quick.
Right. Okay. So next slide, please. So again, this is this draft combines two different concepts, which originally were defined in two different documents. And I think most of the draft is pretty stable. There is one pending open issue, which we discussed in the previous IPPM meetings and also on the mailing list, also in the design team meetings. And so far, we haven't been able to resolve this. Actually, there are two opinions around this. Next slide, please. So just a reminder, we're talking about the question whether we want in the IOM direct exporting header, whether we want to include an explicit hop count field or not. And if we're talking about not, what we mean is that we can use the hop limit node ID data field, which is already defined in the IOM data draft, and that can be used as an alternative. Now, of course, each of these two possibilities has its pros and cons, and these pros and cons have been discussed thoroughly on the mailing list, and actually there's a section in the draft right now which discusses the pros and cons of each of these alternatives. And we heard the same opinions over and over. So I think if people who are non-authors would like to express their opinions about this, that would be great. We would love to hear from other people who are, not authors, and also any suggestion from the working group chairs about how to resolve this would also help.
All right, sounds good. First, I guess, is there anyone else in the working group who's not an author who would like to comment on this? There was a thread on the list about this in May. So. Silence is deafening. Yeah, I think we do need probably just some overall working group input on this. What I think we can, as the chairs, can take an action to kind of review that thread, review that on the document, and discuss with Martin, and then start a thread on the list to kind of do a call to come to consensus and try to summarize it in a way that the group can understand well.
Also, I just want to quickly point out that in addition to the yes or no, and there's a third option to make this field actually optional. That's also discussed in the design group.
Great. So many options. Alrighty. That's all we have on this document?
Yes.
Great.
Any other comments or questions?
Sounds like not. Thank you. Thank you, Tom.
Thanks.
Let's move on. All right. Next up, we have spin bits.
Okay. You can hear me?
Yes.
Okay. Next slide. Okay, a short recap about explicit performance monitoring, EPM. Explicit performance monitoring enables a passive observer, a probe, to measure delay and packet loss only watching the marking a few bits of production traffic packets. It works on client-server protocol, quick TCP. In this draft, we will examine 3 different methodologies: the precise RTT, fin bit plus delay bit, the round-trip packet loss, the packet loss bit, a one-way packet loss square bit plus reflection square bit. Next slide. The spin bit is the first implemented explicit measurement, is optional in the quick protocol. And the idea is to create a square wave that is the length of RTT. Next slide. There are some little limitations. The packet loss, if there is a packet loss on the edge of the square wave, it can change the RTT. If there is out of sequence, the edges can create false edges and false periods. And if there are also, let me say, in the real traffic, if there isn't real traffic for some milliseconds, can change the shape of the square wave. Next slide. So we introduce the delay bit, second marking packets inside one double market packets inside each spin bit period, in order to have a precise point of measurement. If there is the double market packet, the delay bit market packet, we have a precise measurement. If there isn't, if this packet is lost, or if this packet is not created because there isn't real traffic in this moment, we have an approximate measurement using only the spin bit. Next slide. We introduce also a round-trip packet loss using one bit, the PL bit. The idea is to have a statistical measurement, not measuring all the packets, but we create a train of packets, and we reflect twice this train of packets between client and server. In this way, we have an intermediate server can see one packet, complete packet round of the train. So comparing the two numbers that he measured on this train the first time and the second time of the round, it can measure the packet loss between a round trip. To maintain the two trains with the same speed, if the speed of the number of packets in the two directions, the speed of the packets is different, we can introduce some unmarked packet in between the packets of the train. So in this way, we can measure also if the two speeds, download and upload, are different. Hopefully, it works if there are quite packets in both the directions. In case of very, very short session, it's possible that it's not possible to complete the two rounds if there are small number of packets and the measurement can't happen. Next slide. This is more traditional packet loss, the one-way packet loss. The first bit that we use is the square bit, firstly introduced by the draft Ferriot and Chui quick loss bit, and already presented in the quick working group. It creates a square wave of 64 packets. So it's possible for intermediate measurement to count the packet loss between the endpoint and the observer. Next slide. To complete this kind of measurement, we introduce a second bit, the reflection square bit, that reflects the square bit, but not all the packets of the square bit, because the different speed of the two directions can not permit this, but only the average size. Next slide. This is an example. If we have 50% of packet rate in download respect upload, we can have 4 square wave of 64 bits in the upload side, and only 2 square wave of 62, because this is the average between 61 and 63 that arrived to the endpoint, and 63 that is average from 61 and 63 from the other side. So if there's opposite situation with half packet rate upload, 50% of packet rate of download, we can replay the square waves. So a 63 square wave can become 263 square wave, and so on. It works not only for integer square wave, but also for fractionary square waves, because we keep the rest and we insert in the next square waves. There is a method. Next slide, please. Okay, when this is the algorithm that we tested in 2 hackathons, and it works. When the transmission of a new R blocks starts, the size of this square block is set equal to the size of the last Q-market period whose reception has been completed. If during the transmission the R block is terminated, the reception of the last one further Q-market period is completed. The size of the R blocks is updated to the average size of the further received Q-market periods. So is let me say a sliding average. It is freezing when the reflected block is terminated. And it works. The algorithm properties are quite interesting. It works in both cases when the reflection packet number is greater than is received, and when the reflected packet number is lower. And all traffic is measured. All the production traffic has both the Q-bit and the R-bit market. It's different between the previous method that use only 1 bit, that not all the packets are marked for the measurement. Next transparency. Next slide. Okay, so a one direction server can subtract the packet loss measured using the Q-bit to the packet loss measured using the R-bit. So in this case, we can measure in a server on one direction, measure the Q-bit, so the packet loss between the endpoint and the server in this direction, and the end-to-end packet loss in the opposite direction, because the R-bit reflects the packet loss in the opposite direction. Next slide. If we have a packet loss on both directions, we can measure all the packet loss, one-way packet loss end-to-end, and partial packet loss before and after the observer. Next slide. This is the property of the Q-bit only that permits 2-point one-way packet loss to measure the packet loss between 2 measurement points put on the same directions. Next slide. So if we have only 3 bits, as in Quick till now, we have 2 options. The first option is to privilege the round trip measurement, RTT measurement. So we use the precise RTT, spin bit plus delay bit, and one-way and round trip packet loss using only 1 bit. If we privilege the option 2, the measurement of the packet loss, we have only the spin bit for the measurement of round trip type, and 2 bits for the one-way packet loss, the Q-bit and the R-bit in our proposal. Next slide. A short overview on our presentation on OTRFC. Next slide. The idea is to add to this draft or create a new draft with some new ideas. There are some open issues, in our opinion, inside the explicit performance monitoring. The first one is who decides whether to mark traffic. Explicit measurement only work if both client and server mark the production traffic, and it's not so frequent in quick protocol implementation till now. Another problem is the scalability. network probes could monitor all the connections. It's quite difficult in intermediate points of the network where there are a lot of connections, perhaps millions of connections. If they can't, which one to choose, which connection to choose to monitor, and how to monitor both the traffic direction, if not always possible for network probes in case of asymmetric connection. How to answer to this open issue? The next slide. The idea is to put the explicit performance of server also on the user device, mobile phones, PC. There are some answers to the previous issue. La scalability on the user device, there are few connections to monitor. Which connection to monitor? The ones that have problems. User device and network probes can be coordinated. It's possible to set alarm thresholds on the user device and to signal to network probes to monitor only the session with impairments. It's possible both direction monitoring on the user device, and we can also put a rule on the decision if mark or not. The device owner can decide in our idea if mark or not is trafficked and if have or not explicit measurement. Next slide. Okay. The device owner activates explicit performance monitoring in this idea. The decision whether to activate depends from the device owner. He can configure the application browser based on client-server protocols that support explicit measurement. All applications should provide for activation and deactivation of packet marking, providing a user interface or exposing API. So during the client-server handshake, the client will decide whether the marking is active or not, and the server should follow. Next slide. The problem is to who will see the performance data. The performance information displayed on the device if the owner of the device decides to mark, and possibly sent to external body if the owner agrees. The main recipient would be the internet service provider. See user device and network probe coordination point. But this data could also be of interest by the national regulatory authorities or other authorized subjects. Next slide, the last one. So we can conclude that explicit measurements are gaining interest for encrypted transport protocol. Groups became the and working group. The implementation, there are some implementations shown in many hackathons, and the thread on the IPPM and quick mailing list are quite interesting. So it's possible to evaluate the future working group adoption of the document on the basis to give it a place, and welcome questions and comments, especially on the last part that are quite new and quite tricky, I think. Thank you.
Thank you.
Yeah, thank you. This is Ian. I wanted to add one note, just because Tommy and I talked about this draft and it's been, this type of measurement in general. That this working group is definitely not in charge of allocating any bits in Quick in any way, shape, or form. And so, any draft that got accepted, I think, would have to only reference things like Quick as a potential substrate on which you could do this sort of measurement with these mechanisms and not rely on it. So that probably most people understood that, but I just want to make sure everyone's clear.
Yeah, we did kind of talk with area directors and the Quick working group chairs, and I think the measurement work to do the experiments to understand the mechanisms does belong in IPPM, and then we can essentially give recommendations for how various transport protocols can allocate their bits to follow different schemes created here. All right, Igor was first in queue.
Can you hear me?
Yes.
Nope. Yes, thumbs up, thumbs down. Okay. First, thank you very much for bringing this work to the working group. I think loss measurement, and anybody who's heard me before I'm all for it. And just for people in this working group who are not frequent in TSVWG or in Quick, basically just want to point out that we've also had another draft on loss bits presented in TSVWG and in Quick that uses similar step function, so the qubit, and we also use a different mechanism for end-to-end loss reporting, where basically it doesn't require bidirectional observation, it's all unidirectional. It's also both endpoints must agree to it, and it doesn't suffer from possible limitations in terms of like possibly 10-to-1 difference in uplink and downlink packet rates. So that's just FYI. And if there is interest in the working group, I'm happy next time to present our draft. Although it's possible that we're going to meet with the current authors and maybe have something out together as well. But my main thing was to just point out that people who are interested in this read TSVWG or Quick loss bits draft.
Great. And for that particular draft,
and by the way, just to add for that, that's been actually validated, our loss bit draft, for half a year on Akamai deployed servers, and with several ASPs in Europe, been performing really well. So that we have real world, real internet, wide scale deployment, production validation for that.
Great.
That's it.
As a question both for that draft and then this one that we had presented here, it does seem like there's a lot of overlap, and certainly the document here is already kind of cataloging different approaches and different ways to solve the problem. Would the authors be able to get together and propose essentially a combined draft that we could adopt in IPPM to talk about those measurement schemes?
Sorry, I didn't catch.
Essentially just asking if we would be able to have one document potentially as a collaboration between the authors of the two different approaches, the one that was proposed in Quick, at least for the mechanism of measurement, and be able to have that be the basis of something that we can adopt in IPPM.
Okay. Yes, there are, in this document, there are many kind of measurement. We can add another one, it's not a problem. The difference is only about the use of one bit. We use the reflection bit that reflects the square bit, and Igor draft uses the L bit that let me say, export an internal variable that counts the packet loss. So it's not a big difference. Important to have some measurement that measure in the right way both packet loss and delay. Our proposal is also to, in the next hackathon, to have a shared demo that we use 3-bit, one for square bit, one for L bit, and the other for R bit. So we can measure with the same flow of packets, the packet loss end to end with two different methods, and so we can compare. We can use the spin bit implementation of the observer that Ericsson made available on GitHub. So we can work together.
Great. Okay, Martin's in queue.
Thanks for doing this. Plus one what Ian said about what the scope should be of any document we do in IPPM. But I would like you and people working on this draft to think through the privacy implications very carefully. I think this could easily run aground in an IETF last call or ISG review in this sort of unrecoverable way if we don't get this right. The idea of explicit user consent is meaningful user consent is often a very difficult thing to have, and defaults matter a lot. And if the model here is that I call the support line and I turn it on, and otherwise it's always off, that's one thing. If it's browsers are going to decide on behalf of users, that's another thing. And I'm not actually advocating for particular position here, but it's something we should really tread carefully and maybe get some outside review outside the measurement community, which has particular biases. Thanks.
Great. Yeah, I think that's one thing that I don't see addressed in the draft as it is, and I think there's room to potentially adopt this work before then, but any document that we would have as a working group document would need a significant privacy section. Okay, Fabio?
Hello, everyone. Okay, Mauro mostly answered to what I was going to say. I agree for collaboration with Orange guys, just to find a solution that can be good for everyone. And about the Orange One implementation of the LBIT, as Mauro said before, the LBIT depends on variable and events inside the protocol. Our solution instead is detached from the protocol, so it can be applied to quick protocol, it can be applied to TCP, for example, it can be applied to any connection-oriented protocol. So this, I think, is an advantage. But I agree, I totally agree with a collaboration with the other draft guys. Yeah. Okay. Thank you.
Thank you. Go ahead, Giuseppe.
Good to combine the two drafts, and since they want to address the same problem, and it's very good to work together. And then we can also share the experience of to work on a general document that try to solve a general problem like RFC 8321. And then since it's a generalization of methodology, it makes sense. And it's just to mention a use case when we have a good result, and then we are now applying this methodology to IPv6 and so on, and we can do the same. So we can define the general methodology, and you can then go to quick and to TCP and to apply, even if there is the possibility.
All right. Thank you. Okay, so it looks like we don't have more questions in the queue, and we should probably move on for time. I think we have some good next steps here. We will follow up with the authors of the document and the other document to see if we can have a combined proposal. And then if we can get that in time before next IETF, we can have some discussion on the list and potentially call for adoption then. Thank you. Okay, Rakesh, go ahead.
You guys hear me?
Mm-hmm.
Hi, everyone. This is Rakesh Gandhi from Cisco Systems, presenting the draft on PM using a STAMP, simple two-way measurement protocol for segment routing networks on behalf of the authors listed. So there is a companion draft as well for the T1 Lite as well. We won't go through it, but mechanisms are very similar, except that there are two base RFCs. Next slide, please. So we'll look at the requirements and scope, the history of the draft and updates since it was presented in this working group, the summary and the next steps. Next slide, please. So the requirement is the delay and loss PM for links and end-to-end SR paths. Links can be physical, virtual, bundles or bundle members. It's applicable to SRMPLS or SRv6 data planes. Handle ECMP for SR paths, and also the standalone direct mode loss measurement for measuring actual customer data traffic loss. The scope for this draft is a STAMP RFC 8762 as well as the STAMP TLVs. Take advantage of the great work done in the IPPM working group. There is also, as mentioned, companion draft with the scope of RFC 5357 using T1 Lite. Next slide, please. So draft has been around for a year and a half. It was presented last July in IPPM working group in Montreal. The draft had T1 plight as well as stamp from the beginning. And it was agreed with Spring and IPPM working group to progress this work in the Spring working group. But we've been asked to keep the IPPM working group in the loop because there is a lot of base work being done in IPPM working group, especially lately STAMP TLVs. Next slide, please. So it was presented about a year ago in Montreal, and since then we have separated the two, STAMP and T1 blight, into separate drafts. We have added a flag for in-band response, which is used for two-way measurement mode. We have updated the return path TLV to now include the return address. We also define another TLV for destination address. There is a minor registry cleanup and editorial changes. As we went through previously, there is some updates to the STAMP TLV draft, so we will align with that latest updates as next step for this draft. Next slide, please. So we had a pretty good discussion on the mailing list, where to put the control code. And many thanks to Greg and others who contributed to the discussions on the IPPM mailing list. So we have defined a control code field in the STAMP packet at this location, and it is used if you want to get the response out of band or in band. In band is used for the two-way measurement for the bidirectional channel. It's also applicable to non-SR paths as well. This was a comment. So next slide, please. So return path TLV, we have added another sub TLV to include the return address as well. It contained previously the SRMPLS label stack or binding seed, as well as same for the SRV6. Next slide, please. So there are two modes. There is a one-way measurement mode, we call it, where reply can be sent out of band on default IP UDP path. And in two-way measurement mode, reply is sent in band using the control code that we have defined. And it can also use the return path TLV to send a reply on a specific reverse path. Could be a SRMPLS label stack or binding seed, as mentioned in the previous slide. Next slide, please. So we have defined a node address TLV for STAMP, and it can contain the destination node address, and this is useful for segment routing path where destination can be 127.8 loopback address. So it's important that node is the probe is processed by the right node. So we have defined this TLV to identify the intended node. Next slide, please. The draft also defines a standalone LM message for STAMP. There is a corresponding message also for T1 Lite as well, defined in the sibling draft, and it is it's there for efficient hardware counter stamping with well-known locations for the traffic counters. This is the actual data traffic counters carried in the probe messages. It uses a separate UDP port, so there is no real intersection with existing procedure in STAMP or T1 Lite for the delay measurement. So this is really an extension. Next slide, please. So it's an example provisioning model. It's very similar to what's there in the STAMP RFC. What's new here is that you have measurement mode one way or two way, or you have loss measurement mode, which is now defined as a direct mode in this draft. or the delay or loss measurement modes, and which UDP port belongs to which type and all that. It's part of the provisioning model. Recall that there is no signaling either in TWAMP Lite or the stamp. Next slide, please. So this is an example packet format when probe messages are sent over links. The messages are pre-routed over the links. The links can be physical, virtual, lag, or lag members. There are separate ports used for the delay and loss, as mentioned. It's basically the same idea for the stamp as well as TWAMP Lite. The payload is slightly different, that's all. Next slide, please. For SR-MPLS, again, the probe packets are pre-routed or routed over the SR-MPLS or SRv6 policy path, and they use the either MPLS label stack or SRv6 segment list for that policy, but they follow along the path of the policy, so they are routed on a specific path. Next slide, please. And the response, as mentioned before, it can be just IP UDP, or it can be using the control code or return path TLV to follow a specific path of just an IP path. Next slide, please. SR path has a CMP, as mentioned, so destination address can be 127.8, which is used to sweep to traverse all the CMP paths in case of IPv4, and for IPv6, probe would sweep the flow label values in the IPv6 header. Next slide, please. So we welcome your comments and suggestions. So there is this draft for using stamp payload. There is a companion for TWAMP Lite, and both drafts, I think we have presented it last year, and it was presented again in the spring this week. So we do have implementation. We have asked for Spring Working Group adoption, and we would keep the IPPM Working Group in the loop for milestones. And many thanks to the IPPM Working Group members and the chairs for the opportunity to be part of this. Thank you. Any comments, suggestions?
From Greg.
I have a couple questions. So this control for the return path, is it applicable to the test session, or you envision that might change from packet to packet?
So it's a particular, it will not change for a session. So you have a session, and that session could be a one-way or two-way, and it would not change for packet to packet for that session.
Mm-hmm. Thank you. So then, looking at the model that you use, so using the centralized controller to provision sender and reflector, would it make sense that provisioning of return path, the mode of reflector to send reflected packet back to the sender, will be part of the data model?
So in segment routing, it's a stateless on the reflector, so there is no state. Reflector is basically just responding to the packet received. So there is no state, and there is no segment list there, no binding state. There is nothing there to, so it just uses the information from the packet to reflect the packet back.
But that's only one case. Why it's only this case? Because again, if we look at, for example, stamp, the reflector stamp-wise could be stateful or stateless. You assume only one mode that you cannot associate return path, label stack, or SRH for SRv6 on the reflector with a specific stamp session ID. and the source and the sender identity. I think that makes it easier. And I do have a concern of updating the stamp base format for the type. If you want to communicate this with a test packet and you're already sending it in TOV, why not to include it into TOV itself? So to how to interpret it on the reflector.
Yeah, so to answer the first one, this is the stateless model. So SR, there is no state. That's how the segment routing extensions are used. That you avoid having states on the other side. So the information is carried. The state is carried in the packet itself. So this is the way segment routing is designed. So this is the reason why the information is there in the packet itself. Label stack can change on the imposition side, and reflector would have no. There is no signaling to in segment routing to go back and forth like you would have in RSVP. So the state is always in the packet itself. So this is why you'll see that there is a return path TLV, and there is a it expects that you send me information this certain way. And I mean, if there is a stateful mode in non-segment routing networks, then it's fine to use, provisioning or maybe some external signaling mechanism.
So you mentioned that the return path might change, but that contradicts idea that it would not change for the duration of test session, because if it has to change, wouldn't it be better to have a new test session? Because you're effectively measuring for the two-way measurements a different path.
No, it's the same session, and the path can change, and it will be stored in the session state at the ingress node. Yeah, path can change. It doesn't. We don't want to impose a new session, stop the existing session and start a new session because a reverse path has changed.
So, in the interest of time, don't want to have this go on too long, but I think this is an important conversation. Could we take this to the list? I don't know if Greg, you want to just shoot into.
No. Of course, yeah. Let's continue in the list.
All right, thank you. Thanks for bringing up this conversation.
Yeah, thanks, Greg.
All right. So we are now done with our official agenda time. We're into lightning talks. These are 5 minutes each. We have time for 4 of these. Apologies to the people who will not be able to get to, but please do bring up your drafts for discussion on the list. So first we have.
Okay, can you hear me?
Yes.
No. Okay. So this draft is mainly about concern for the overhead issue when applying IOM in IPv6, and we suggest several potential solutions accordingly. Next slide, please. So the key issue here is because IOM trace mode needs per hop processing, then it must be kept in the IPv6 hop by hop option extension header. But HBH extension header must also be the first extension header in IPv6. So there are 2 issues about this applying IOM trace mode in HBH extension header. The first issue is about the header can be very large, so each node can accumulate dozens of bytes of data. And consider the number of hops, the potential overhead can exceed can be very large in one word. And also a more important issue about it is that in the incremental mode, each node will add some more data, so make this size changeable. which means if there's some other headers need to be processed, then its position is keep floating, so you cannot easily pass it. So it's either prohibitive, as pointed by Tom, or even if possible, then it makes the packet processing much harder. Next slide. So we have several workarounds about it. The first is when in doubt or we cannot afford the overhead, we might just avoid using it at all. Or in some special case, like in the SRv6 mode, we can apply the IOM as a SRH option. So then, which means we will only apply IOM on the SRv6 node, but not all the IPv6 nodes. But those solutions are apparently not ideal because in many cases, we do need IOM to cover all the IPv6 nodes. Next slide, please. So we have several possible solutions. The first one is we can separate the IOM data instruction part and the data part. So we still keep the fixed size IOM instruction header in the HBH extension header, but we postpose the IOM data in another extension header after the routing header. In this way, the HBH is small and its size is also fixed. But the problem is where we will put the data. Shall we introduce some new extension header or put it in some TLV field in some existing extension header? So that's a problem about it. So the second potential solution is use the concept of segment IOM export we proposed before in another draft. So for there are two variations about this. The first, we can just fix the number of hops we will accumulate the IOM data. And whenever we reach that fixed number of hops, we just export the data out. Then we can make room for the following nodes to continue to collect the IOM data. A second approach is applied for the SRv6 specifically. For example, whenever we reach an SRv6 node, we need to handle the routing header. We just export the IOM data first. Then now the HABH header only includes the IOM instruction part, so its size is also fixed. So this makes it easier to access the later extension headers. So the third option is to use IOM direct export mode. So which means basically every hop will directly export data. So without needing to accumulate the IOM data in the packet. So that can also keep the header small. Next slide. So basically, in this slide, we list the current proposed solution, which is just put the IOM trace option header entirely in the HBH extension header, and the other 4 alternatives we proposed in this draft. So each of them has its own pros and cons. It's all summarized in this in this table. And for the time's sake, I will not repeat it. And so if you are interested, you can look at our draft for details.
All right.
So next slide.
5 minutes. Yep. So
yeah.
next step.
Yeah.
Do you have we have time for one comment? If anyone has any. Okay. Doesn't seem like it. Thank you. Let's move on. Thank you, Hoya. Cameron.
Can you hear me?
Yes. Please go ahead. And I'll start.
Hello, everyone. I'm Kieran from Huawei. And this is about the Yarn data model for IOM. Yeah, next slide. Oh, yeah, this draft was initially posted in 2018 and presented on IETF101 and 102. We got comments from Greg, Richard, and Tom. Thanks all for your comments. we have evolved several versions to align with the latest IOM data draft and the IOM directly export draft. And the latest version corrected the admin type things as suggested by Tom in the mailing list, including the reference copyright, tree diagrams, and the correct reference to the proof of transit and so on. Next. And the model structure is like this. The model is organized as a list of profiles. As suggested by the working group, each profile container is enabled by the corresponding features. So the device do not need to support all the features. Each profile associates with one flow and the corresponding IOM information. The flow is typically identified by ACL and can be defined flexibly. We support 5 profiles in this draft: the incremental tracing, the pre-allocated tracing, the direct export, proof of transit, and end-to-end. And multiple IOM data types can be encapsulated into the same IOM header. Next. And here, the pre-allocated tracing option will create the pre-allocated space for each node to populate its information. And next. The incremental tracing option contains a variable node data field, and each node allocates and pushes its node data immediately following the option header. And next. The direct export option is used as a trigger for IOM node to export IOM data to a receiving entity. And next. The IOM proof of transit data is to support the path or service function chain verification use case. This part is imported from the proof of transit draft. And next. The IOM edge-to-edge option is to carry the data that is added by the IOM encapsulating node and reinterpreted by the IOM encapsulating node. Next. Yeah, that's the IOM model. As the IOM data draft is getting mature and stable, I think it's the right time to get the model adopted so that we can build the whole system. Thanks and comments.
Thank you. Get a whole minute back. Any comments on this one? Do any of the other IOM authors want to comment? Rick.
Yeah, maybe quickly. I think this is now looming in the back for a while. I think we need something config, no matter what, and I think that could be a good candidate. It's in progressing in lockstep with a data draft, given that the data draft is pretty mature by now, as we heard from Martin earlier on. How would you suggest to go and move this forward? Should we go and continue to progress this as an individual one for now? Or when would you foresee a good time to go and really get it adopted for working group? Should we wait for the data draft to be RFC, or should we consider something earlier?
I mean, since we are pretty mature on the data draft, I think we could look at doing this earlier, and just kind of keep it in the working group and keep updating it. That would seem reasonable. So maybe if we can get some more reviews of this on the list, or at least opinions from people, that would be helpful for giving.
Okay, that sounds good. We can go and inspire a couple of people that are more like coming in from a Yang angle to go and
Exactly.
give it a closer review. I'll
Yeah.
try to work on that. Thank you.
Thank you.
Okay, thank
All
you.
right. Next up, Kelly. Please go ahead.
Okay, so well, hello everyone. This is Yali from Huawei, and the list after we defined optional TLVs which can be carried in STEM test packet to measure the performance data at every intermediate node that STEM test packet travels. So let's look at background and the requirement. So as we know, the STEM can measure the one-way and the round-trip performance, but we can see that the performance of intermediate nodes that travels the paths are invisible, and on the other hand, we want to try to measure the intermediate node performance, but we need to configure the STEM instance at every intermediate node. So let's lead to the complex of the OEM in such a large scale networks. So this draft we try to define optional tailwinds to realize the performance measurements at every intermediate node. So as we list here, the first TLV is the IOM tracing data TLV. So this TLV we define that the test pack can carry this TLV to action the performance measurements as defined the IOM data fields in the IOM draft. And the second one is the and the third one is the forward and backward hop by hop delay TLVs. So these two TLVs we try to measure the delay by per hop along this path. So this three TLVs we define here as we want to add the update of the STEM TLV extension draft. Next, please. So okay, this is the format we defined in this draft. So the important thing we think is the length we need to predefined because as we'll know, because the step use a symmetric packet, so we need to set the value of the length depends on the number of nodes and the IOM bitmap we set in the IOM header. So this is the length value we need to set. And another one is the node data copy list. Here we defined it as a variable length field. So this can be used to copy the IOM trace data list into the reflector test packet. So here we list the brief procedure here. As we can see that the sender need to insert the header into the test packet and carry back the IOM tracing data in the reflector packet. So yeah, this is the IOM tracing data TLV. Next, please. This is a forward hop by hop delay TLV. So here we also defined the length field, and another one is the node left field. So the length value we also must be set according to the number of the intermediate nodes and the timestamp format. So the node left, it means that the number of the listed intermediate nodes the packet need to visit. along the path. And another large part of field is timestamp tuple list. Here we use to record the ingress and the egress timestamp per hop. And also we follow the stamp test season procedure here, and carry the tail width into the test packet. Next one, please.
We are at 5 minutes, and we're also out of time. So can we just jump ahead to the end of this?
The backward is similar. And the next step, we welcome everyone give the comment and the input here, and welcome to cooperate with others to refine this document together. And that's all. Thank you.
All right. Thank you, Yali. Any quick comments or questions on that one? All right. Thank you again.
Thank you.
Okay. Thanks everyone for making it through your last IETF session of the week. Hope everyone is doing well and staying safe wherever you are. And yeah, I think we had a productive meeting. So thank you.
Yeah, thank you. And definitely take a look at the slides that we didn't get to present. If make sure there's anything interesting, take it to the list.
Yep. All right. See you next time.